When selecting the appropriate wire size for radio frequency welding machines, several factors must be considered to ensure safe and efficient operation. These factors include the amperage requirements of the machine, the length of the wire run, the type of insulation on the wire, and adherence to the National Electrical Code, or NEC. Utilizing wire size charts and calculators is essential for making informed decisions. Firstly, determine the amperage, or amps, required by the radio frequency welding machine. This information is typically found on the machine's nameplate or in the manufacturer's specifications. The amperage rating indicates the amount of electrical current the machine will draw during operation. Secondly, measure the length of the wire run. The wire run is the total distance a wire must travel from the power source to the radio frequency welding machine and back. Longer wire runs result in greater voltage drop, which can affect the machine's performance and potentially damage its components. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire due to the wire's resistance. To compensate for voltage drop, a larger wire size may be necessary. Thirdly, refer to a wire size chart or calculator to determine the appropriate wire size. These charts and calculators take into account the amperage, wire length, and allowable voltage drop to recommend a suitable wire gauge. Several resources are available, including online calculators from Welding, Southwire, Ideal Industries, Home Depot, and Lowe's, as well as charts from Electrical Know-How. When using a wire size chart, locate the row that corresponds to the machine's amperage requirement. Then, find a column that corresponds to the length of the wire run. The intersection of the row and column will indicate the recommended wire size. The chart may also provide options for different types of wire insulation, such as THHN, THWN, or XHHW. The type of insulation affects the wire's ampacity, which is the maximum amount of current the wire can safely carry. THHN, or thermoplastic high heat nylon, is a common type of insulation used for general purpose wiring. It is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THWN, or thermoplastic heat and water nylon, is similar to THHN but is specifically designed for use in wet locations. XHHW, or cross-linked polyethylene high-heat water-resistant, has a higher temperature rating and is suitable for both wet and dry locations. Always consult the manufacturer's recommendations for wire size and insulation type. The manufacturer may have specific requirements based on the machine's design and operating conditions. For extended wire runs or higher amperage requirements, it is crucial to consult with a qualified electrician. An electrician can assess the specific installation conditions and ensure that the wire size and insulation type are appropriate for the application. They can also perform calculations to determine the actual voltage drop and ensure that it is within acceptable limit. Additionally, the NEC provides guidelines for wire sizing and installation. The NEC specifies the minimum wire size for various applications based on amperage, voltage, and other factors. It also provides requirements for overcurrent protection, such as circuit breakers and fuses to protect the wiring and equipment from damage in the event of a fault. Some key tables and sections in the NEC related to wire sizing include NEC Table 310.15b16, which lists the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on insulation type and temperature rating. NEC Section 210.19 outlines the requirements for branch circuit conductor sizing, including the need to account for voltage drop. NEC Section 310.15 provides general requirements for conductors, including ampacity correction and adjustment factors for ambient temperature and the number of conductors in a raceway. When selecting wire size, consider the following factors. Firstly, the ambient temperature. Higher ambient temperatures can reduce the ampacity of a wire. If the wire will be installed in a hot environment, it may be necessary to use a larger wire size to compensate for the reduced ampacity. Secondly, the number of conductors in a raceway or cable. When multiple current-carrying conductors are installed in the same raceway or cable, their ampacity must be derated to prevent overheating. The NEC provides adjustment factors for the number of conductors in a raceway. Thirdly, the type of load. Some loads, such as motors, require larger wire sizes due to their inrush current. Inrush current is the surge of current that occurs when a motor starts. The wire size must be adequate to handle the inrush current without causing excessive voltage drop. Fourthly, future expansion. Consider whether the radio frequency welding machine's power requirements may increase in the future. If so, it may be wise to select a larger wire size to accommodate the potential increase in amperage. Using a wire size that is too small can lead to several problems, including overheating, voltage drop, and potential fire hazards. Overheating can damage the wire insulation and surrounding materials, potentially leading to a short circuit or fire. Voltage drop can cause the radio frequency welding machine to operate inefficiently or malfunction. It can also damage the machine's components. Always err on the side of caution when selecting wire size. It is better to use a wire that is slightly larger than necessary than to use a wire that is too small. Using a larger wire will ensure that the radio frequency welding machine receives adequate power and will reduce the risk of overheating and voltage drop. Here's an example scenario. Suppose a radio frequency welding machine requires 20 amps and the wire run is 50 feet. Using a wire size chart for THHN insulation, it may be found that 12 American wire gauge, or OLG, copper wire is suitable for this application. However, if the wire run were 100 feet, it may be necessary to use 10 AWG wire to compensate for the increased voltage drop. And if the wire were installed in a hot environment, it may be necessary to use 8 AWG wire. Remember to always consult the NEC and local electrical codes for specific requirements. Electrical codes vary depending on location, so it is important to follow the applicable codes to ensure a safe and compliant installation. In addition to wire size, it is also important to select the appropriate type of wiring method. Common wiring methods include conduit, cable, and direct burial. Conduit is a rigid or flexible tube used to protect wires from damage. Cable consists of multiple wires bundled together in a protective sheath. Direct burial wire is specifically designed for underground installation. The choice of wiring method depends on the application and local codes. Conduit is often used in commercial and industrial settings where wires need to be protected from physical damage. Cable is commonly used in residential settings. Direct burial wire is used for underground installations such as landscape lighting. When installing wires, it is important to follow proper wiring practices. Firstly, always disconnect power to the circuit before working on the wiring. Secondly, use appropriately sized wire connectors to ensure a secure and reliable connection. Thirdly, properly ground all equipment to protect against electrical shock. Fourthly, neatly organize the wires and avoid sharp bends or kinks. Fifthly, label all circuits and wires for easy identification. Sixthly, inspect the wiring regularly for signs of damage or deterioration. In conclusion, selecting the appropriate wire size for radio frequency welding machines is crucial for safe and efficient operation. Consider the amperage, wire length, insulation type, and applicable codes. Consult with a qualified electrician for extended runs or higher amperage requirement, and follow proper wiring practices to ensure a safe and reliable installation. When dealing with electrical systems, safety should always be the top priority. If unsure about any aspect of the wiring, consult a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect against electrical shock and fire hazards. Some additional considerations when selecting wire size. Firstly, the material of the wire. Copper and aluminum are the two most common materials used for electrical wiring. Copper has a higher conductivity than aluminum, meaning it can carry more current for a given wire size. However, aluminum is less expensive than copper. For most applications, copper wire is preferred due to its superior conductivity and durability. However, aluminum wire can be used in some cases provided it is properly sized and installed. Secondly, the type of terminations. The type of wire connectors used can affect the ampacity of the wire. Some connectors are designed for use with specific wire sizes and materials. Always use connectors that are rated for the wire size and material being used. Thirdly, the environment. The environment in which the wire is installed can affect its performance. Wires installed in corrosive environments may require special insulation or coatings to protect them from damage. Wires installed in wet locations must be rated for wet locations. In addition to the NEC, other standards and guidelines may apply to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. It is important to be familiar with all applicable standards and guidelines to ensure a safe and compliant installation. When troubleshooting electrical problems, it is important to have a good understanding of electrical principles and wiring practices. Use a multimeter to measure voltage, current, and resistance. Visually inspect the wiring for signs of damage or loose connections. If you are not comfortable troubleshooting electrical problems, consult a qualified electrician. Never attempt to repair electrical equipment or wiring unless you are properly trained and qualified. When working with electrical systems, always follow lockout/tagout procedures to prevent accidental energization. Lockout/tagout procedures involve disconnecting power to the circuit and placing a lock and tag on the disconnect switch to prevent someone from accidentally turning the power back on. This is a critical safety measure that can prevent serious injury or death. Furthermore, it is always advisable to keep accurate records of all electrical work performed. This includes documenting the wire sizes used, the wiring methods, and any modifications made to the electrical system. These records can be helpful for future maintenance and troubleshooting. They can also be required by local codes or regulations. When performing electrical work, it is important to be aware of the potential hazards and to take all necessary precautions. This includes wearing appropriate personal protective equipment, or PPE, such as safety glasses and gloves. It also includes using insulated tools to prevent electrical shock, and it includes working in a well-lit area to avoid accidents. When dealing with high-voltage systems, it is essential to have specialized training and equipment. High-voltage systems can be extremely dangerous, and it is important to follow strict safety protocols to prevent serious injury or death. In summary, selecting the correct wire size for radio frequency welding machines is a multifaceted process that demands careful consideration of several variables. These variables encompass the amperage prerequisites of the machine, the distance of the wire run, the characteristics of the wire insulation, and compliance with pertinent electrical codes and standards. To ascertain that the chosen wire size is appropriate for the specific application, it is imperative to consult wire size charts and enlist the expertise of qualified electricians, particularly when confronted with extensive wire runs or substantial amperage demands. Electrical safety should invariably remain the paramount concern during any electrical task. Possessing a comprehensive understanding of electrical principles and adhering to established safety protocols is of utmost importance in mitigating the hazards associated with electrical systems and safeguarding against potential injuries or incidents. Moreover, meticulous record-keeping of all electrical work, encompassing wire sizes, wiring methodologies, and any modifications implemented, is crucial for future maintenance endeavors, troubleshooting activities, and ensuring adherence to local regulations. By diligently adhering to these guidelines and consistently prioritizing safety, one can assure the dependable and secure operation of radio frequency welding machines and other electrical apparatus. And always remember, when in doubt, seek guidance from a qualified electrician.